Hi, my name is Kuldeep Bhati. Welcome to Minerva Statistical Consulting course on Introduction to R Programming Language. For this course, you do not require any programming experience, so beginners are welcome. In this course, you will learn R, a powerful, easy to learn and widely used programming language, and you will explore how R is used for basic statistics and data analysis. R programming language is used almost in every industry from astronomy to manufacturing. I have divided this course in 5 sections, and after each section there is a multiple choice question test to evaluate your learning. We will use R Studio platform for this course. So let's start our first section. In this section, we will learn a brief overview on R, how we can use statistical features in R, installation of R and R Studio platform, setting working directory in R, and our first Hello World program. Let's start with a brief history on R first. So what is R? R is a programming language and environment for statistical computing and graphics. R was created by Ross Iaka and Robert Gentleman at University of Auckland, New Zealand. They started the project in 1992, and with their first version they came out in 1995 with a stable version in 2000. So R is an extension of S programming language combined with lexical scoping semantics. R is called functional programming language also. So let's understand two terms, lexical scoping and functional programming language. In functional programming, programming is done with an expression or declaration instead of statement. In functional code, the output value of function depends only on the arguments that are input to the function. And what is lexical scoping? Lexical scoping is sometimes called static scoping. Scoping means a range of functionality or visibility. And what is lexical scoping? Lexical scoping is sometimes called static scoping. Scoping means range of functionality or visibility of a variable. In lexical scoping allows variable to be declared within a specific scope and it is only accessible within that region. This makes R of a more functional programming language. To understand functional programming and lexical scoping further, I have created two functions, increment1 and increment2. Increment1 takes an integer value and returns an integer value with an increment of 1. Increment function 2 takes an integer value and returns an integer value with an increment of 2. So we expect output value of z here to be 6 and the output value of f is 7. To understand more about functional programming, output value of function increment1 depends only on the argument y that is input to the function, and that is same true for increment2. Output value of function increment2 only depends on the argument x that is input to the function. So why functional programming is so important? Functional programming behave similar to mathematical function and it is very transparent. From this example of increment 1, we know that if we pass an integer value to function increment 1, it will always return an integer value with increment of 1. To understand more about scoping, if we look at increment 1 function and increment 2 function, scope of y, variable y, is only in function increment 1 and scope of x is only in function increment 2. If we change the value of y to x in increment 1, both functions have same variable name x, but both variables are unrelated. Scope of first x is only limited to function increment 1 and scope of second x is only limited to function increment 2. So in real life, programs are huge and complex, so they are divided into smaller modules, and in modules you have many functions. Scoping is crucial in modular programming, so a change in one part of the program does not break an unrelated path. That we have seen, for example, here, that if we change x uh, in increment 1, the output of z will remain the same, and same as output of increment function 2 will remain the same. So now we have clear understanding on functional programming and lexical scoping. And one thing we know, that without lexical scoping we cannot do functional programming. So let's move back to our slides. So R is a GNU package and it's freely available under GNU General Public License. This means that it's an open source. You can download it, you can redistribute n number of times. The source code for the R software is primarily written in C, Fortran and R. In next slide, we will look at statistical features in R. Statistical features in R. In R, you can do simple with R and using external library packages. You can do simple statistics like regression, power analysis, t-test, mean, mode and median. You can make predictive models in R also, like time series analysis, classification, clustering, Poisson regression, logistic regression. You can plot different graphs in R like bar chart, pie chart, histogram and box plots. You can do some interactive graphic as well in R. R is highly extensible through the user submitted packages for specific function or specific area of study. So anybody can submit anybody can submit packages in R. There are some guidelines that you have to follow before you submit your package. As of January 2016, 7,801 additional packages available at Comprehensive R Network, CRAN, Bioconductor, GitHub and other repositories. CRAN is a network of FTP and web servers around the world that store up-to-date version of code and documentation for R. Bioconductor provide tools for the analysis and comprehension of genomic data. It is primarily based on R programming language but contain contribution in other languages. GitHub is a web-based Git repository hosting service. It offers all of the distributed version control and source code management functionality. You can open a free account to host your source code. If you are a public repository, anybody can download your code so you can share your source code. Due to S heritage, R has stronger object-oriented programming facilities than most statistical computing languages. Everything in R is an object. Here an object is a bit of self-contained code and data. A key aspect of object approach is to break the problem into small understandable parts. So it is like divide and conquer approach, We will be using objects in R all along, like we have string objects, integer objects when we are assigning variables, list objects. Uh, Another strength of R is static graphics, so which can produce public quality graphs including mathematical symbols. So if you want to create scientific graph in R language and want to show like mathematical symbols or formula somewhere on the chart, you can use plot math package also in R. Our dynamic and interactive graphics are available through additional packages. So if you want to plot dynamic graphs, you can use ggplot, plotly and shiny. So this was all about introduction on R. We will install R and R Studio now. I am using Windows 10 PC. So I will show installation of R and R Studio for Windows. Installation is similar for Mac and Linux. So to download R, we have to go on CRAN R project. So I'll just click on CRAN R project, and here you can see there are download links for Linux, Mac and Windows. This is a Windows PC. So I'll just click on download R for Windows, and I will click on base. I will click on R download R 3.3.2 for Windows. This is the newest version available. I have already downloaded exe file for R Studio and R. So we will start with installation of R first. So I'll click on this exe file. So it's showing setup language English. You can set up any languages that you want. So I'll click OK here. Welcome to our Windows 3.3.2. So I'll click next. This is the copyright information. So as I already said, it's a GNU General Public License, so it's freely available. So anybody can download it free and distribute it free. I'll click next. It shows program files 3.32. It shows me the path where this will be installing. I'm using a 64-bit machine, so I will not download 32-bit files. So the current selection requires a 119.7 MB disk space. I will accept the default setting, startup options. Menu folder is R is correct. I will create a desktop icon here. So now it is installing R on my PC. So setup is finished for R now. So I'll click on finish, and you can see that it's already downloaded R here on my PC. Now we will install R Studio. R Studio is a convenient interface for R. So I'll click yes here. Welcome to R Studio setup wizard. It shows me the installation location, and it requires 472 MB space, so nearly 500. Menu folder, yes, and so setup is finished. So I will click on finish, this one. We have set up R and R Studio. So now we will start with R Studio. Studio desktop app. We will use R Studio console window. So we can do interactive programming, as we know that R is a functional language. So this is the console window. So first thing we will write is hello R. So for a string we always have to write either in inverted commas. So we have used double inverted comma here. So it's hello R. Second thing that we will set up our set up our working directory. So first we will get the working directory. So what is the current working directory? So our current working directory is C user Dimira documents, and if you want to see the file in the current working directory, we use ls command. So it shows all the files in current working directory. So to set up our working directory, so let's set up our current working directory on desktop. So we'll use folder name R. So now we will use set wd command, and we will give the path C users desktop R. So now we have changed our working directory from documents to R. The reason why we have we are using a set working directory, so that we can save our workspace, so that we can use in future. We can change our working directory from session, set working directory, and we choose directory here, and we have to select the folder whatever. So we have selected the desktop and R, select folder. So set working directory, desktop R. We can save the whole workspace using save dot image. So we have saved the whole workspace here, and if you want to quit, you will use Q command. So now in this folder we can see our R workspace and the history that we have used and the commands that we have used. So congratulations, you have finished. We have finished our first section. In section 2 we will learn entering input in R and data types in R. Thank you. Welcome to section 2. In this section we will learn entering input in R console and different data types in R, like scalar, vector, matrices and data frame. So first we will open our R data frame. So I will click here on R history file. So now I have opened R Studio again. Here you can see history of previous commands that we have used in last video. We can access these previous command by key up and key down. So in console window, if we do key up, so you can see all the previous commands. First, here we will see assignment operator. Assignment operator in R is used by using less than and minus sign followed by a minus sign. So if you use a variable x and we assign the value 1 to it, so and we type x, so the value is assigned, the value of 1 is assigned to x. So if you print the value, we will get the output 1. We can use equal to sign as well. So if you look at x equal to 2 or 1 and we type x again, so we'll get output 1. We can use x for printing strings as well. So hello as we have previously seen in last video. Okay, I have used the boolean expression, so I will use x minus hello r. Forgot the inverted commas. So now x equal to hello r. We can also write comments also in our program with using a pound sign. So I'll write a comment also here, x minus. So if you want to write, we will just use pound sign, and I write this is comment. So R ignore everything, right to the pound sign. So if I type x here, I get hello R. I can use print also to access the value of x. So it's giving output hello R. If I want to remove a variable, I can use rm function and the variable name that I want to remove. And if we try to type x now, it will say object x not found. So next we will see data types in R. Data types in R. Data type in programming language is a set with values having predefined characteristics. R has wide variety of data types including scalar, vector, numerical logical characters, matrices, lists and data frame. So first we will understand scalar arithmetic operation, plus, minus, multiplication and division. So we will go back to our RStudio platform. So let's type x equal to 2, y equal to 3, and if you want to do addition, we just type x plus y. So it gives result 5. For subtraction, we use y minus x and it will give answer 1. We can do multiplication, y multiply x 6, division y slash x, and we can do a reminder. We can find remainder and quotient also using. So first we'll find remainder. So 20, so we'll use 2 percentage sign 3, so it gives remainder of 2. And if you want to do quotient, then we can do 20 divide, and in between we will use one slash 20 slash 3. Here it will give quotient 6. We can do power function. So 2 will use caret 3, so it gives 8. We can do a complicated mathematical convention in R also, like x equal to 2 y. So we can write formula in R, y equal to x plus 1 divided by x minus 1 plus 1 divided by x, and we can find the value of y here, 3.5. R provide rounding function also. So ceiling always round up. So x equal to, so ceiling 1.66, if I write, it will give 2. So it always round up, and if I write floor 1.66, floor always round up down. We have round function also. Round function gives up and down. So if we look like, if we type like round 1.66, it will round up, and if we write like round 1.3, it will round down. We can use higher mathematical function in R. So if you want to evaluate square root, so we'll write square root function 2, we'll get 1.4114. We can do exponential as well, so we'll write exp 2. We can use log function also, log x, we can write 0.693. We can use sine cosine as well, so I can write here sine pi divided by 4.707. Pi value I can print 3.14. We can do Boolean expression also to evaluate either true or false. So I can do like 3 plus 2 greater than 5. It will give me a false. I can write like 10 minus 4 equal to 2 plus 2. It will also give me a false condition. We can use AND or OR operator for Boolean expression. AND operator is true if all the expressions are true. OR operator is true when one of the expression is true. So let's see by example. So 5 greater than 4. For AND operation, we will use ampersand sign. So 3 greater than 2. Here the both expressions are true, so we will get true result. For OR operator, we will use a vertical bar. So if we select 2, so in this one condition is false, but still we will get a true result as one condition is true. Here we can use NOT operator also. NOT operator evaluates true to false or false to true. So if we have expression like 4 greater than 2, so NOT operator will give a false result to us. So that's the end of scalar arithmetic. Next we will understand vector data types. Vectors are sequence container representing arrays that can change in size. So first we will generate a vector. So x 1, 2, 3. So we have, so here x is in vector with 3 elements 1, 2, 3. C stands combine here, so it's combining 3 elements 1, 2, 3. We can generate vector from like 2 is to 2 colon 8. So we can generate a vector from 2 to 8. We can also generate a vector using sequence function. So we'll write sequence. So from 5 to 30, and if you want an increment by 5, just write by. So it will generates a sequence from 5 to 30 with an increment of 4. And if you want to a repetitive vector, then we can generate repetitive vector by wrap function. So I'll just type wrap 2 colon 3 times equal to 3. So it generates a repetitive vector, and this times means that how many times we are repeating this 2 to 3 pattern. So we are repeating 3 times. And if you want to repeat each elements of a vector, then we can write